This next section will talk about how to name alkanols. Alkanols are formed by substituting the functional group OH for a hydrogen bonded to a carbon in an alkane. So we're talking about alkanes, all single bonds. So we have a carbon chain, carbon-hydrogen chain, and in place of one of the hydrogens, we'll have this OH group. The general formula for an alkanol is R-OH, where R represents the rest of the alkane, the parent alkane, and then the OH group is attached to it. The procedure for naming alkanols is the same as what we've done so far. So after this slide, we're just going to jump into some examples. The big thing we have to keep in mind is that the numbering starts at the end nearest the OH group. Regardless of other substituents, we start numbering closest to the OH group. And remember, we name our alkanes with an ending ANE, so like hexane, octane, things like that. We're going to take that E off of the end and replace it by this suffix OL. So instead of hexane, we'll say hexanol. Instead of methane, we say methanol. Okay, so those are the big differences. We start our numbering nearest the OH group, and our ending is replaced by this ol suffix. All right, so here's example 1. We have a structure shown here, and we need to identify the carbon-carbon chain and ultimately name the molecule. So step 1 here is the same as it's always been. We need to identify and name the main chain. So that's our parent carbon chain, the longest carbon chain we can find. So this one is pretty straightforward. We can see if we start here, 1, 2, 3, 4, 5, 6. This is our 6 carbon chain. And remember that a 6 carbon single bond chain is called hexane. Hexane. Once we've identified the main chain, we have to number the carbons. And because we see this OH group here, we have to start numbering from the end that's closest to the OH group. And that would be on the right-hand side. We're going to start from the right. 1, 2, 3, 4, 5, 6. So the OH group is coming off of carbon 3. If we had started on the other end, we would be on carbon 4. So we have to start at the end closest to the OH group. So just to summarize, I indicated the numbering on the diagram, and remember the numbering starts on the right-hand side in this case because the OH group is nearest the right end of the main chain. Now we need to identify our functional group. Often this step is like also substituents, right? So any substituents are functional groups. So we can see right here, we have our OH functional group. All right, so the next step, once we identify that we have an OH group, is to determine what carbon is it bonded to. So because we did the work of numbering our carbons already, we can see that it's bonded to carbon 3. And finally, now that we've done all this hard work, we can simply name the molecule. And so we'll start with what carbon our OH group is on, and so it's carbon 3, and then hexane, and then we remove the E and we replace it with OL. So we get 3-hexanol. All right, so here's a summary of everything we did in naming this molecule, and just as a reminder, it is 3-hexanol. We replace that E in hexane with OL. All right, so in example 2, we have another molecule here that we need to name. And in this case, you can see we have a functional group and a substituent. Okay, and I've compressed some of our steps here too as we're becoming more and more familiar with how to name these molecules. So the first thing we need to do is identify and name the main chain. So I'm going to start counting and try to find the longest carbon-carbon chain. So if I start here, I have 1, 2, 3, 4, 5, 6, 7, 8. So this is my longest chain here. 8 carbons, and 8 carbons is octane. Octane, okay? Okay, now we need to number the carbons, and there is both a functional group, an OH functional group, and we have a substituent here. But we need to start our numbering on the end closest to the functional group. So if I number from left to right, I would get 1, 2, 3, 4, 5. If I start on the right and go towards the left, I get 1, 2, 3, 4. So this OH group is closer to the right end of this molecule. So I'm going to start numbering from here. 1, 2, 3, 4, 5, 6, 7, 8. All right, you can see the numbering indicated on the diagram that we just talked about, and also a description for why we started on that right-hand side. Now we need to identify the functional groups and substituents and what carbons are they bonded to as well. So we can see there's an OH group on carbon 4. And then this is a single carbon group. This is a methyl group on carbon 6. All right, so as a summary, we have an OH group at carbon 4 and a methyl at carbon 6. So now we just take all of that and name the molecule. So we have 6 methyl, 4 octanol. All right, so here's a summary of every step of this example, and of course here we have 6 methyl, 4 octanol. All right, here's example 3. In this formula, the side groups are in parentheses and are bonded to the preceding carbon. So do you see this in parentheses and in parentheses? That's a substituent group or a functional group bonded to the previous carbon. Okay, this can also be determined by counting bonds, since the carbon with the side chain will obviously have fewer hydrogens. So let's identify and name the main chain, keeping in mind that carbon in parentheses is not a part of our main chain. So we have 1, 2, 3, 4, 5 carbons in the main chain. All right, so a 5-carbon chain is pentane. Pentane. Now we need to number the carbons, and since we have a functional group, OH, we're going to start our numbering closest to this end, which is on the right-hand side. So I'll number 1, 2, 3, 4, 5. Remember that we don't count the carbons in parentheses, since those are in side chains, not the main chain. Once we've identified that the OH group is closest to the right-hand end, we start our numbering from the right-hand end, as you see indicated on the diagram. And now we need to identify the functional groups and the substituents, as well as the carbons to which they are bonded. So in this case, that is the groups that are in parentheses. So I have an OH group, and it's on carbon 2, right? So it's bonded to the preceding carbon, is what we were told. in the setup for the problem. And then also I have a CH3 group, which is a methyl group, bonded to, again, the preceding carbon, so that's carbon 4. Okay, so an OH group on carbon 2 and a methyl group on carbon 4. Once we've done the work of finding our main chain and our functional and substituent groups, we can go ahead and name the molecule. So let's start with our substituent, which is 4-methyl. And then we have our OH group on carbon 2, which is what makes this, instead of pentane, we'll take off the E and add the ending OL. So 4-methyl 2-pentanol. All right, so here's a summary of all those steps we took in example 3 to get to that final name of 4-methyl 2-pentanol.